All right, so on our block, this is your week 2 lesson for the admissions for IV therapy. Today we're going to talk about primary and secondary engineering controls. Maybe. There we go. So environmental controls are an important part of sterile compounding because no matter how good your technique is, if you're not in a clean environment, your preparations will not be sterile as well. So the main, I guess, parts or pieces of sterile compounding is like the IV room, clean room, or whatever you want to call it. There's different names. So that's the whole shebang. A lot of people just call it all the same thing. Really, there's an ante room, a buffer room, and then your primary engineering control, which is like your hood. These environments, the air is cleaned. Having clean air is a big part of this. You also need to have clean surfaces, but the air is what will really get you. It's cleaned through HEPA filters, high efficiency particulate air filters. It's an important part of this. And then there's different ratings for how clean the air is, and those are your ISO classifications. So, general IV room design. You're going to have your ante room that separates you from the main pharmacy. You're going to have your buffer room, which holds your hood. It separates the hood from the ante room. And then if you have a negative room for hazardous compounding, usually it'll be off to the side. This is not to scale, of course. It'll be off to this side or the top or wherever else, somewhere different. So the ante room is your transition between the compounding room and the rest of the pharmacy. The ante room is where you wash your hands, put on your garb, all that kind of thing. Generally, your drugs will be stored in here, but not always. Then the buffer room is your actual IV room. And that's where you'll do your actual work. Generally, your fluids will be stored here, and your supplies, like your syringes and needles and all that kind of thing, are stored here. Sometimes drugs are stored here as well, but I mean, that all depends on your exact location. And then the hood is your direct compounding area. So, HEPA filters. Basically, these are fiberglass webs of crisscrossed fibers, and they're stuck between normally aluminum sheets, but any kind of metal sheet that just gives them shape. And according to regulations, they have to remove particle size at 0.3 microns or larger. So 0.3 microns, that's 0.3 micrometers. So you have millimeters 1,000 times smaller, and then another third smaller than that. So these work very well. There's efficiency requirements for the American and European use. In practice, you're not going to see a difference between these two numbers. There we go. Which, I mean, you can detect the difference, but realistically, you're not going to see any meaningful difference between these two. So there's different filtration mechanisms that go into this. The important part is your particles are coming through, they're going to hit a fiber in one way or another, and then they're going to stop in the filter and not exit the filter into your compounding area. If you're interested, then you can get very much into this, this field and how these work. But I don't think that's on the test, and I'm not going to dive into it too deeply. So the classifications of different environments, ISO class 1 through 9. ISO is the International Standards Organization, and they make these regulations. So you can see that we have different allowable particle sizes for each ISO environment. The big ones that you'll need to know are ISO 5, ISO 7, ISO 8, and ISO 9. These are what you actually compound in. Regulations require an ISO 5 for your direct compounding area, and then they require an ISO 7 for your buffer area, and then an ISO 7 or 8 for your ante area, which I'll get to that in just a second. Which I think is actually on this previous slide. So I'll get to that in a second. ISO 9 is just about anywhere else. ISO 6, you just don't really see in healthcare because it's not as good as an ISO 5 that you need to compound in, and it's better and more expensive than an ISO 7, which is what you need for the room. So it's just not very common. I'm sure it exists somewhere, but I have not ever encountered it myself. ISO 4 through 1. If you think of like when people are assembling like satellites and spaceships and that kind of thing, they're wearing like the full hoods and the complete bunny suits and everything's covered in white. That's kind of ISO 1 through 4. These are very exacting. I believe they might be used in manufacturing, making the fluid bags, making premixes, making your sterile vials. I'm not 100% sure, but I think they might be used in that in healthcare. So there's two different rating systems. There is the Federal Standards 209E or FS clean room class, and then there's the International Standards Organization's section 14644-1, which is your ISO class. The clean room class, these numbers are proportional to how many particles are allowable per unit of air. It's not a one-to-one, but you can think of it like that. A lot of times you'll see the FS class whenever you're trying to buy your hoods or you're trying to set up a new room. You don't normally talk about cleanliness in terms of FS clean room in everyday practice. And then another part of maintaining a clean room is your air exchange rate. You need to move a certain amount of air every certain amount of time. The standard unit is air changes per hour. So the entire volume of the room or the environment that you're working in, so the hood, needs to be cycled out this many times per hour. Of course, if you're in a big space like the ante room or the buffer room, you're going to have a much larger volume and you're going to have a lot more air to move. Also, you need to have fewer air changes, so it kind of balances out. And then in a smaller space like the hood, you're going to have a smaller volume, but you need to change it a lot more because you also need to keep a cleaner environment. So secondary engineering controls is a convoluted name for the rooms. The primary engineering controls is a complicated name for the hoods. So your buffer area needs to be an ISO 7. So if you're going from the hood to the rest of the room, you need to have an ISO 7 there. In your ante room, you can have an ISO 7 or 8. If you can have an 8 if you only have positive rooms attached to it. If you have any negative rooms attached to it, you need to have an ISO 7 in here. The reason for that is air will get sucked from the ante room into your negative room. So you need to have a sufficiently clean ante room to maintain your clean space in the negative room. Now the negative room is it's a buffer room just like the other, just like a positive room. So you need to have an ISO 7 in the room and an ISO 5 in your negative hood. So I touched on before, ISO class 9 is basically anywhere that's reasonably controlled. Unless something is really going wrong with your environment, it's going to pass an ISO 9. Part of like colony growth and that kind of thing are the reasons that these won't get certified, but in terms of air cleanliness, basically anywhere is going to pass an ISO 9. ISO 8 is kind of your first level of keeping things particularly clean. So like I said before, this is generally going to be your garbing area, and it is not suitable for compounding. ISO 7 is your next level of cleanliness. You will need to know these things. I'm not sure how common they are on the exam, but I'll ask questions about it. So ISO 7 is your most common number, I guess, classification. You'll see this a lot. The main thing is you need to keep a certain amount of pressure and that kind of thing. So ISO class 5 is your actual direct compounding area, or DCA. D, C, A. You can tell it's a D because it looks pretty. So here we have these requirements. And you can see that this person is doing something very bad here. Don't do it like that. I believe you've touched on this in your lab section. Do not block your first air. But this is the cleanest environment that you'll find in a hospital. So primary engine controls, the hood, the cabinet, whatever you want to call it. It's the DCA. There's three main types: the laminar airflow workbench, which is the horizontal hood, the biological safety cabinet or vertical hood, and then the compounding aseptic isolators or compounding aseptic containment isolators, or those are generally called a glove box. And they're meant to provide an ISO class 5 to do your actual sterile manipulations. So LAFWs are the most common type of hood in compounding pharmacies. And the way that these work is you have laminar airflow. Laminar means that it's all in one sheet. Everything is the same speed. So if we look at this from the side, we're going to have, let's go with blue for air. All this coming out at the same speed. The air is coming out in sheets almost. You can't, it's a very smooth airflow. And the reason for this is it keeps all the particles moving outwards. That'll be a good particle count. So all the particles are getting moved outward. There's no swirl or anything to keep them in there. Now, if you have something like a desk fan, then it's a beautiful desk fan. So you'll have different zones of speed. You'll also have non-linear flow where the air will be getting sucked around and going in circles. And in that case, you're going to have, bacteria or contaminants can get all over the place, and it can also loop back around and it can essentially hover in the air whenever you have the turbulent flow. So the laminar flow is a really important part of this. And then of course, behind this, there's a grate at the back of this hood. It's not very easy to see here, but this grate is, behind that is your HEPA filter. So the next type is biological safety cabinets or BCSs. These are vertical hoods. In medicine, you're going to see double isolation hoods. That means that things on the outside of the hood aren't going to go in, things on the inside of the hood aren't going to go out. So it's two directions of isolation, double isolation hood. Normally these are called chemo hoods because they're suitable for hazardous compounding. Now, these are pretty conceptually similar to the laminar flow hoods, the horizontal things, just turned 90 degrees in terms of airflow anyway. So the airflow is coming down, and again, it's a laminar sheet. It's all coming down, and then you're going to have returns, air returns that'll essentially suck out the air as it reaches the bottom. These are run around, they're along the backs, and along the front. You can't see it on the front, but it's graded on the sides. There's also grades on the back. You can see the holes in there for the air return. So air will get sucked into those, and then it'll get sent through a post filter to remove harmful contaminants. And then the air will be sent off to be vented wherever it's going to be vented. And that's not just like a one-step filtering process. There's more to it. And then from the outside air, there's going to be slight air currents that will keep air from exchanging. And then there's the suction will suck air from the outside straight in instead of letting it enter the actual hood. So these are the isolation hoods. You can see that there's a glass sheet there. And one important thing to remember if you're going from the chemo hood to a positive hood is you lose your glass sheet. Whenever I would do hazardous compounding, a lot of times I would actually rest my head against the glass because it was just more comfortable. And then you can bring your items really close to you because it's behind the glass, but you cannot do that in a laminar flow hood. So just remember whenever you're switching environments. Now the final type is the CAI or the CACI. These are glove boxes. These are a huge pain to work with. You'll see these in like very hazardous compounding in terms of medicine, which you're not going to do very much of unless you're manufacturing items. Some locations will have this. And then for very sterile preparations like manufacturing, you can see these. Now, you can see the person here is they're probably doing something extremely sterile, like the manufacturing or they're assembling pieces or something like that, because they're wearing a full bunny suit, tall boots, they probably have like a full face mask on, and then they're going into the glove box. So the way that these glove boxes work is there's two doors here. So there's this outer door, and then you can see the handle to the inner door there. This is an airlock system. You'll take your items, you'll put them in through this outside door, you'll close that outside door, go into the gloves, open the inside door, take the items out, and then you can close the inside door and start working with them. And then to have your items taken out, you do the same thing by the opposite order. Now, the big difference between a CAI and CACI, CAI will usually vent into the room. CACI will absolutely not. This is a hazardous compounding environment. You can think of it as a lot like the BCS, just in a different form factor. Same way that the CAI is in a different form factor than the laminar fluids. Now, in these, your airflow will generally be from the top down, generally. These are a huge pain. Now, one of the advantages of these is there's regulations where you can put these in just about any room. You can just plop them down and start working them. So you can see here, this person is not wearing any garb. This lab coat is not considered clean garb, but she's not wearing a mask. She's not wearing a hairnet, none of that. She's just wearing safety glasses. So that is an advantage of these. Now, if you look at this, you can see that these gloves are very bulky. They don't fit very well because the gloves have to be big, and the gloves and the sleeves had to be big enough to fit any average person in the pharmacy. Whereas in other kinds of environments, you can wear the gloves that actually fit you. So you can see how much tighter this goes on our fingers and how much easier it will be to manipulate things. You all have experienced having gloves that are too big, gloves that are too small, sure. But this is your CACI. Another thing about these is you are sharing these sleeves with everybody else in the pharmacy. So long sleeves they're technically not allowed, but you have these like arm socks almost that you can put on. They're supposed to like keep all the oil and gunk from getting into the sleeves. Those do, in my experience and practice, these do not get used like they're supposed to be because some people just go on without them. These are also generally cheaper than maintaining actual room. So you'll see them a lot in like small locations. So you need to maintain this environment. It's not just to have the fans going. You need to keep a cleaning schedule, and that's there's directions for this in USP. And then also there will be directions from the manufacturer. So you'll need to wipe the deck after every single preparation. Just take an alcohol wipe and wipe it down. You'll need to, you should also clean or change out your sterile gloves every time you enter and leave the room, and also at least every 30 minutes. So a lot of times this will coincide with your each preparation. Now in practice, I see people using gloves a lot longer, and as long as they're clean, it's not the biggest deal. You just want to make sure you hit that 30 minutes. So you need to clean the hoods, the surfaces, and the floors every shift. That's the interior. You need to clean the ceiling, the light box. You need to clean the back. You need to clean the sides. You need to clean the deck. Now, you can, the two items that are used for this is a germicidal sporicidal. Normally that's Paradox, but there's other options too, like there's a clean side, Paradox. Paradox is basically super vinegar mixed with hydrogen peroxide. And it smells terrible. The smell just gets into everything. Technicians will normally go kind of nose blind to it after a bit, and it won't like bother them. You can definitely smell it, but it won't bother them. Something that I have found is pharmacists cannot stand the smell because they are not exposed to it very often. Um, so you're going to use that. Then you're also going to do 70% sterile alcohol, which will be isopropyl alcohol. So these are the two, so sporicidal, germicidal, and your sterile alcohol are the two fluids you'll use to clean everything. So these you'll use on your hoods. One thing to make sure you, whenever you're cleaning the hood, on the back where you have that mesh grating, do not spray any liquids into that. You're going to spray your cleaning tool and then wipe across the surface. If you spray into it, you're going to degrade your HEPA filter. So then every week, you're going to take apart some of your components. You're going to take out the returns on the hoods, like the BCS, and you'll get these, you'll do a more in-depth cleaning. Monthly, you'll have the big clean, which is where you'll clean every single surface in that room. You're going to take apart the hoods. You're going to clean the outside of the hoods. You're going to clean the back of the hoods. You're going to clean the walls and the ceilings in the room. You're going to wipe out the cabinets, the inside of the cabinets, like everything. Another big part of this is making sure you have the proper training for the staff. So that's your garbing procedures, your sterile technique or aseptic technique, and then also record keeping. This will get a lot of people. You need to keep a record that you did the training. And then also you need to keep track of your facility function. So how old and efficient your HEPA filters are, how many air cycles you're getting, your surface properties. If you have a hole in the wall, you're going to have a problem. If you have scratches all over the place, then it's, those can actually grow bacteria because they'll give them a place to anchor to. So that's something to watch out for. And, there's something to think about. It'll come back to me. So when you're getting inspected, there's a few different parts to this. One part is the colony forming unit. This is like a microbial growth test. I'm sure you all have seen like the agar plates. What we have, it's the same material, but it's in a straight stick instead of the circular plate. And whoever's doing the inspection will just go around and stick those on various surfaces in the pharmacy. A lot of times you see them put on the outside of the hoods, the inside of the hoods, and then high touch surfaces like doors. And then you'll see some that are just in oddball places in the pharmacy. And that's why you need to clean every single surface. You'll have your pharmacy manager do these every month at least. And then you'll have your state and commission inspectors doing them whenever they come in. So then you also have the smoke pattern test. You don't see this in practice very much and you can see in these pictures, the smoke is coming out, and these are very laminar flows. Some of these angles are a bit misleading, but you can see how straight these are coming out. And you can also see whenever you have something in the way, it'll whip around. That's why you need to make sure you have clean first air for all your preparations. Now, one of the reasons that you don't see this in practice very much is whenever you have that smoke going, you're blocking first air, and you are actively making the environment not good for your preparations. So if you're making something that's actually supposed to go to a patient, you can't do this. And most locations don't have just spare bags and syringes and drug that they're just going to throw away to do this test. So you'll also have your HEPA filter inspection, and then your physical facilities, which is where people are looking for cracks, dents in the wall, that kind of thing. So the way that these are inspected, it's kind of neat. They have this tool. It's like an inside out umbrella. Not doing a great job of drawing here, but it's this big old fabric design, and it'll has like a box in the middle of a detector, and that'll detect how many particles are coming through, how much airflow you have, the size of the particles coming through. This the upside down umbrella will cover the entire front of the hood, and then they'll set that up. They'll run it for almost like half an hour actually, and then they'll see how it's doing. And then the BCS is a very similar process. but it's kind of two-step. They'll have one set that's just over the opening, and then they'll do the same full glass mechanism as well. So that's how they'll be certified. You have to get them inspected every 6 months. Your HEPA filters need to be changed at least every year or more often if they're not performing as you would expect. And whenever the people that do these inspections and certifications, which is what you need to get them certified every 2 years or every 6 months. They will also generally clean and do maintenance on these hoods, so they'll swap out your filters and that kind of thing as well. So main reasons that pharmacies will fail inspections. This is an important part for you all, because if you fail, it's going to be your fault. So you want to make sure that if you have an issue like a damaged equipment or your floors or ceilings are messed up, you need to be vocal about that. And this is some CYA, and then it's CYA, and then it's really good for the patient. For a while, we had a broken light diffuser, and every day we would tell the manager about it. And the manager would say, "I know, we need maintenance to come out." But anyways, so main reasons that pharmacies will fail is they aren't getting enough clean air to their HEPA filter, which is why you need to change it out. The airflow is not going as it should. That's why you need a certification. The technicians will be able to tune in your fan systems. Your temperature and humidity are outside of physical limits. Those are defined by USP, and also ISO. You have too many colony forming units of bacteria or fungus growing in your controlled environments. Depending on the ISO classification you're going for, you have a different allowable number. For an ISO 5, I believe you get 2 gross in the entire environment. So these can be very strict. And like I said before, the damaged equipment, walls, floor, ceilings, those can get you in trouble. I once had a state inspector come in, and we got a written warning because there is a small scratch in the paint on the outside of our hood. So, that's a very specific thing, but some of your inspectors will be very specific about this. And then something that will get a lot of people is your staff training. They'll do the training, but they won't keep a log of it. You have to keep a log of this material, or else it doesn't count. The inspectors will watch how you garb up. They'll watch how you prepare things. So that's another thing that's important to have. I just had the thing that I touched on. So pass-throughs. So you don't just, it's the BCSs, or sorry, the glove boxes aren't the only thing with pass-throughs. This is a pass-through. And the way that these work is you'll have a door on each side, and these are designed so that you can't have both doors open at once. You'll open one side, put the drug in, close it. The technician inside will open their side, pull the drug out, start compounding with it. Then they'll put it back in the box, and then you'll swap it out, and then they'll be going off the rest of the pharmacy into the patient eventually. So, that's pass-throughs. Now, I have seen some good designs where you can actually only open one side at a time. I've seen some bad designs where it's just super easy to open them. And it's kind of funny because the bad designs are also the biggest. The small ones that I saw that worked well, they're like a foot square. The big ones, they're like 3-4 foot square. So I don't know what the design philosophy with that is. I'm guessing it's like most things, the people that designed it and bought it are not people that use it. You'll see that a lot in pharmacy. All right, so that is your primary secondary engineering controls. You will need to know, for your certification test and for this class, you don't really need to know your different subtypes of your primary engineering controls. There's like the class, A2, no, it's 2A. It'll be Roman numerals like that. You have your class 2B, which class 2A is like your laminar flow hoods. Class 2B is your vertical flow hoods. And then you'll have your class 3s, and these are your glove boxes. I put up like a PDF of that goes into these a little bit on Blackboard. Please do take a look at that. You'll see those come up a lot in your job training. You have to do like learning modules. I see them come up a lot. That's about the only place I see them. Otherwise, you'll just know what your pharmacy has, and that's perfectly sufficient. All right, so that is the lecture. I'll just put it on Blackboard, and then everything will be nice.